this is part of 313 that I skipped. It was like the second part of it because we were just getting into polar, and I didn't want this to get all lost and confused in your brains with the polar stuff. Complex numbers, not a brand new concept for you. Complex numbers, remember all of our real numbers are complex numbers, but they can be written in this form, but maybe be a 0. So this could be like 3 plus, well, in this case right here, this is 3 plus 2i. Okay, 3 plus 2i is a way to write those. So a complex number can be understood as a point in the complex plane, and it can be determined by corresponding rectangular or polar coordinates. When the complex number has the rectangular coordinates AB, okay, so if I have rectangular coordinates AB, it can be expressed as this. So here's this point 3, 2, which just looks like a normal old point that we are used to. However, our axes are not x and y like we are used to. Instead of this being x, this is the real axis. And instead of this being y, this is the imaginary axis. Imaginary. Okay, so it's the imaginary and the real axis. That's why 3, 2. That's not an x and a y, that's an a and a b, and you get a plus bi. Okay, so this is what this says is the complex number 3 plus 2i can be represented as the point 3, 2 in the rectangular coordinate system or in the rectangular complex plane. Right, so earlier in the notes, when we talked about 313, this has actually come up a few times. We know that x equals r cosine theta, y equals r sine theta. Oops. So using these identities, we can also express a complex number in polar coordinate system. When the complex number has polar coordinates r theta, it can be represented as r cosine theta plus I r sine theta. Okay, so here we go. This says a complex number is represented by a point in the complex plane. The complex number has the rectangular coordinates of -2, 2. So this is different than just straight up converting from polar to rectangular, right? But we still have to know some things about it. We need r cosine theta, r sine theta. So I need r and I need theta. So to find that, we're going to find it the same way. If you remember that r is equal to the square root of this squared plus this squared. So the same thing happens here. -2 squared plus -2 squared. So that's going to give me the square root of 4 plus 4, which is the square root of 8, which is 2 square roots of 2, but we're going to just let it be that. Then to find theta, we're going to go from, we need the tangent inverse of this. So the tangent inverse of -2 over -2, or actually, I don't think I wrote it like that. I think what I wrote it as, I think I said that tangent theta is the same, I mean, it's the exact same thing, equals -2 over -2. So that means that tangent theta is equal to 1. So then we want to know from 0 to 2 pi, when does tangent equal 1? Well, our angles are pi fourths and 5 pi fourths. Okay. And I really only need one of them because they're going to give me the same answer. So now, because this is a complex number and I'm getting this, I'm not putting it in ordered pair r cosine theta, comma r sine theta. I'm using this right here, and it's going to look like this. R, which is the square root of 8, times the cosine of, okay, so I got two angles over here, and I said they were going to give me the same thing. They do for tangent, but I need to decide which of these two angles I actually want. If I was to plot this point here, I'd go to -2, -2, I end up in the third quadrant, so I need to use this angle. So it's the cosine of 5 pi fourths plus I times r, which is the square root of 8, times the sine of 5 pi fourths. Okay, so now let's clean that up. Square square root of 8 times cosine of 5 pi fourths is negative square root of 2 over 2 plus I times the square root of 8 times the sine of 5 pi fourths, which is negative square root of 2 over 2. Now, we have to be able to clean this up because this would definitely be a multiple choice question, not a free response question. So we can't make up math here. We're going to put these over 1. Okay? When you multiply square roots, you can multiply everything underneath together, but not the stuff that's not. So this will give me the square root of 16. Square root of 16 is 4, so that's a negative 4 over 2, which gives me negative 2 plus, and then this would be same thing, 16, and then that'll give me, I don't guess I want plus, I can do minus 2i. And I know what you might be thinking, well, couldn't I have just stuck an I on that and added them together? No, because it doesn't always work that way. This was probably not the best example to have, or you might not believe that. But yes, you have to do all of that work. Okay? All right. So now, let's say we have a complex number that is represented by a point in the complex plane. Using polar coordinates, the complex number can be expressed as this. Express the complex number using its rectangular coordinates, x, y. Okay, so we need to actually figure this out here. So I'm going to do 4 times, well, the cosine of 7 pi sixths, that is going to be negative square root of 3 over 2 plus I times 4 times the sine of 7 pi 6 is going to be negative 1/2. So this is going to give me negative 2 square roots of 3 minus 2i, I believe. Yes. So if that is how I write my imaginary number, then its rectangular coordinates are negative 2 square roots of 3, negative 2. So there's your basics about complex numbers in the coordinate system, polar and rectangular. I'm going to say the same thing I did at the end of 315, is that if this is on the test, it is one question max. If don't spend hours and hours trying to make sense of 100% of this, because there's way more stuff going on that you need to spend that time on. Now, if you want to and this makes sense and you want to dive deeper and you have questions, please come ask me. I'm not telling you to skip over it, but if it freaked you out at all, not worth it. Okay?